Okay, so what are the latest versions of Java you have worked on?
Latest, I have worked on Java 8.
Still Java 8 only? So you did not get the chance to work on Java 11, 17 and all?
Uh, we are using the Java 17 version, JDK, but the features we are using of Java 8 mostly.
Okay, okay. So do you know method reference in Java 8?
Yeah, I know that. So method reference, we can say that is kind of short way to write the Lambda expression to call a method. So instead of writing the full Lambda, we can directly refer the existing method by its name. So I mean, basically, it makes it for more readable. So when we use method references, when we are just passing behavior and the Lambda is only calling an existing method. So, for example, let's say any class name is there and it has any, one static method is there. So, for example, let's say, so we have a parseInt method in the integer class, right? So, instead of writing the whole, we can just say integer reference, that is through the colons, two double colons, and then we can say just parseInt. And also in case of system out println, we can say system dot out, then method referencing, and then println. So those kind of situations are there where we can use it.
Okay, so one question in case of method referencing. So can method referencing replace all lambda expressions? So wherever we are using all lambda expression, can we replace all of them using method referencing?
No. We cannot do that. So method references can only replace the lambda that is directly calling the existing method. So if any kind of manipulation or any logic is there inside the method call, then we cannot use it. So for example, let's say we have let's say uh, like for each is there. Okay, it's any stream is there, any list is there, and on top of that we are applying for each. Okay, and again inside that for each, suppose um, we are just giving some condition, like if uh, or we are just updating the whatever the inside is coming to uppercase. So some logic is there here. So in this case we cannot use it. But yeah, if it is a straightforward print, then we can use.
Okay, okay. Okay, so in Java 8, do you know what are terminal and non-terminal operations?
Yeah, so we have a map, filter, sorted, then a distinct. So all these are intermediate operations basically. So they are used in the middle. So basically these methods they return the stream itself, and these intermediate operations are they are just like kind of a transformation thing we can say, but it does not trigger any kind of execution. Okay, and and terminal operations are like which we end at the end. So like we have collect for each, count, and find first. So all these comes under the terminal operations. So basically in the end they consume streams, and they trigger processing, and they produce the some a specific result. Okay, so they are, we can say, kind of eager kind of evaluation, and the non-terminal operations are kind of the lazy, we can say. Okay, so until unless that is the intermediate operations are connected with the terminal operations, the execution does not take place. So yeah, so this is the difference between these two.
Okay, okay. So what is the difference between map and flat map?
Map and flat map. Yeah. So map basically transforms each element in a stream and wraps the result in another stream. Okay. But if the transformation itself returns a stream like nested collections or something like that, then it will be like a stream of a stream it will return. So in that case, we can use flat map. Okay. So
Any small example you want to give?
yeah, like for example, let's say we have arrays.as list we are saying, and inside that, let's say we have two another list. Okay, one more is arrays.as list we are saying a b, and then again comma we are again arrays.as list cd. Okay, so if suppose that we are applying a stream of this, and then whenever we are saying dot flat map, and then we are trying to print it. Okay, so in this case it will like flatten the things like a b c d all will be like it will come together kind of, and we can print it all together. But if we say instead of flat map, if we say map, so in that case what will happen that it will print the nested thing, you know. So using map, it will give a stream of list, not individual elements. So that's the difference actually.
Okay, okay, okay. So can you modify list while using stream?
Actually, we should not do that. So streams are not, I mean, meant to be modified while processing actually. So in the terminations, like in the terminal operations like for each and all, so we are not supposed to do that. So doing that will lead to the concurrent modification exception. So yeah, so we don't do that usually.
Okay, so what is the difference between find first and find any?
Yeah, find first returns the first element of the list or whatever it encounters in the order, and find any can return any element. So basically, suppose we have the A, B, C, D is there, and as soon as we are saying find first, in that case it will return A. But in case of A, B, C, D, we have in that case it can return any one of them.
Okay, so in which case you are going to use find any?
Find any is more kind of useful in case of parallel streams actually. So if the performance matters a lot and we don't care about the which element to we want to fetch first, so in that case we can use find any. So whenever we are using the parallel stream, then find any may perform better.
Okay, okay. Okay, so do you know inheritance and polymorphism in OOPS?
Yes, I know that.
Okay, can you explain them?
Yeah, sure. So polymorphism basically means poly means many and morphism means forms. So basically, whenever we have the same method name but it behaves differently, so that situation we say as polymorphism. So it can be of basically two types. So one is the compile time polymorphism, which is also called method overloading, and another one is the runtime polymorphism, which is method overriding. So method overloading happens when we have multiple methods in the same class with the same name but different parameters. Okay, so it can be like number type or order can be different, so those things. Okay, so the decision of which method to call is made at compile time. Okay, so let's say we have a class. Okay, and there let's say we have let's say add method is there. Okay, and add method, one add method accepts int a int b. Okay, another add method is there which is double add, and that accepts double A, double B. Okay, so here the parameters are different. Now which add method will call, that depends on the whatever the input parameter coming to it. So that will be decided at the compile time. Okay, so based on that, the corresponding methods will be invoked. Okay, so now coming to method overriding. So method overriding, basically when child class provides the specific implementation of the method that is already defined its parent class. Okay, so suppose any class is there, and in that class we have, so let's say we have class animal, and that has method sound. Okay, and again we have another class called dog extends animal, so that is extending animal, and there also we are mentioning sound. So the sound will be different, the implementation will be different for both, right? Now whenever, let's say, we are saying new of dog, and whenever we say like sound of that object, so it will basically pick the sound method of the dog object. So that's what is the overriding.
Okay, okay, good. And how about inheritance?
Yeah, so it basically allows us like one class to inherit the properties and behavior of another class. Okay, so like let's say we have a class called vehicle, which has some common methods like a start, a stop, and maybe any variable like a speed. Okay, now if we want to create a class like car, bike, or anything else, so we don't need to rewrite those same methods again. Instead we can let them inherit from the vehicle class. Okay, so that basically means the car and bike will automatically get all the properties and method from the vehicle class, and we can also add extra features if we want. So yeah, so that's what is the inheritance.
Okay, okay. Okay, so what are the types of inheritance,
Types of inheritance. We have single inheritance,
Mm-hmm.
then we have multi-level inheritance, then we have hierarchical inheritance.
Okay,
So yeah, so these are the ones. So single inheritance is basically, that is the basic inheritance. So one child class inheritance inherits from one parent class. So that will be single inheritance. Then multi-level will be like, let's say we have a um, let's say we have a class that inherits say from a class, another class. So that itself again inherited from the another class. So like we have a, so A is there, so A extends B, and again B extends C. So like that. So we have this multi-level inheritance.
okay, okay, that's fine. Now tell me one thing. Do we have anything like multiple inheritance?
Multiple inheritance.
Yes.
Yeah, multiple inheritance with classes, no, we cannot support. I mean, Java does not support with classes, but with interfaces, yes, it does support. So Java does not support multiple inheritance with classes. Why? Because to avoid the ambiguity and complexity, especially in case of method conflicts. So let's imagine we have two parent classes that have the method with the same signature. Okay, so if the child class inheritance from both, and you call that method, then we cannot know like which one to use. So that confusion is known as basically the diamond problem. So that is why it does not support it. And but suppose if we have interface, in that case we can do, because the method inside the interface has not been implemented. So it doesn't matter, I mean, any class which is implementing those two interfaces. So I mean, anyway the declaration we have to do inside this class only, and already that method has not been implemented. So yeah, so that's the thing about the multiple inheritance.
Okay, okay. Okay, so have you worked on collections?
Yeah, I have worked on that.
So in collections, have you worked on tree map, hash map?
Yes, yes, I have worked on them. So basically, both hash map and tree map are parts of like map interface. Okay, so basically, map means key value pairs. So um, data we store in the form of key value pairs. So hash map basically have no orders in is guaranteed. That is what is happens in the hash map. So keys are stored based on their hash code. So when they iterate, the order is random. So we cannot even change. Okay, but in case of tree map, that is sorted map basically. So it sorts stores the key in a natural ascending order. So like alphabetical for string or numerical for the integers, or we can provide the custom comparator also. So that is how it is stored in the tree map. So that's the difference between these two.
Okay. How about null keys and values? So in hash map, what happens with null keys and values, and what happens in tree map?
Yeah, in hash map allows one null key and multiple null values can be there. But in case of tree map, it does not allow null keys, but it allows null values. Okay, so tell me one thing, why doesn't tree map allow null keys? Any idea? Yeah, yeah. So the main reason why tree map does not allow null key because like it maintains the sorted order, right? So for sorting we need the comparison. Like suppose we have to sort between two elements, so we have to compare between them, right? Tree map stores the keys in a sorted way. So that stores the key either using natural ordering that happens via comparable, or it can also do the sorting using the custom comparator if whatever we provide. Okay, now uh, in either of the cases it uses either dot compare to or compare method internally. Okay, so suppose if we are using a tree map and we are putting the key as null and then value, then internally whenever it is going to use compare to or compare method, so it is going to throw null pointer exception. Okay, so that's the reason why I mean it does not allow a null key.
Okay, fine. So can we override a private or a static method in Java?
No, a private and static method we cannot override. So basically, private methods are not visible to subclasses. So that's the main reason why we cannot even inherit this, and so we cannot override it. And static methods like that belongs to the class. Okay, so there is no question of like creating the instance of that and all. So if we declare a static method with the same name in the child class, so it's method hiding, not overriding. So yeah,
Okay, so what is the default value of the local variables in Java?
default values of local variables.
Yes.
So I mean the local variable can be of various data types. So which data type?
Any data type. So let's say we have a class test, okay? And under that test we have, let's say, a print value method is there, okay? And in that print value, if we write int x, okay, and we are simply trying to print it, system.out.println x, okay, so what will be the output? You understood the question?
Yeah, yeah. Uh, so if inside the method, if we have given int x, but we also have to declare it outside of that. I mean, um, so x is a local variable, and if we try to print out this one, it will uh, I mean throw the compilation error, because we cannot do it like that. So we have to initialize at the class level actually. So at the instance variable it should be there, then only we can use it directly. We cannot use inside the method.
Okay, so can you serialize a static variable?
Can we serialize a static variable? No, no, no. We cannot serialize it. So a static variable basically that belongs to class. So not to the instance. So serialization is all about the instance state. Okay. So static fields are ignored during the serialization.
In Spring Boot, so what happens when you run the Spring Boot application? So behind the scenes, what happens?
Yeah. So as soon as we start the Spring Boot application, the main class with Spring Boot application that triggers Spring Boot application dot run, and then it kicks off the chain of events. Okay, so like there can be many, like we whatever the embedded server we have with the Spring Boot, let's say Tomcat is there or any other server is there, that will start, and beans are auto scanned and registered. So we have component scan, right? So under the packages, whatever the beans are there, they are scanned, and then all the configuration properties are loaded, and the application context is initialized. Okay, so after that, if anything fails during this bootstrapping of the Spring Boot, then like it can be missing of configuration, or there might be some circular dependencies. So it will stop right there, and with a error, it will say like whatever the issue is there. So yeah, so that's what happens whenever we run the Spring Boot application.
Okay, so can you tell me what is at the rate of Spring Boot application?
Yeah, basically it is the combination of three other annotations, like at the rate of configuration, and then at the rate of component scan, and at the rate of enable auto configuration.
Okay, so what is auto configuration?
Yeah, auto configuration in Spring Boot. So that is basically the setting up the beans based on what's in the class path. Okay, so let's say for example, if it finds Spring Boot starter data JPA and a data source, so it will auto configure JPA and repositories, so we don't have to do it manually. Okay, so that's what it is.
Okay, and suppose if we want to disable it, then what we do?
Yeah, if you want to disable it, so I think we have a exclude command, not command, exclude, like tag we can say. So we have enable auto configuration, and under that we can write exclude, and whatever we want to exclude, that package we can give. So yeah.
Any other way is also there?
Any other way? Sorry, I'm not sure about that.
Okay, okay. Okay, so what is dispatcher servlet?
Yeah, dispatcher server is basically that is basically we say as front controller in Spring MVC basically. So whenever suppose any HTTP request comes in, so it goes through the dispatcher servlet always. Okay, so from there it routes to the like write controller, so that dispatcher servlet will route it to write controller, and so once it reaches to controller, then further the processing happens and it returns the responses, like it might be model view or it may be the response entity, so based on whatever the code is. So um, yeah, so that's what is the dispatcher servlet.
What about in Spring Boot?
In a Spring Boot, I have never seen it being done manually. So I think we don't do it manually in Spring Boot, and it happens. I mean, Spring Boot all. I mean, that does it. That auto registers it for us. So yeah. So I mean, I have not done it.
Yeah, okay. Okay, do you know service discovery registry?
Yeah, yeah. I know that. S- So in microservices setup, we usually have multiple services running on different host transport. So service discovery basically. So basically, Eureka we use for the service discovery, and whenever suppose any request comes in, and so it comes through the API gateway, and then the API gateway suppose from there it has to communicate to some service, so it goes to the this Eureka service discovery, and there like the all the services are registered over there. So that is what is service registry, and all the IP addresses of all the services are dynamically generated over there. So we can say at the rate of enable Eureka client to make the service discovery enabled. So this way we use a service discovery and service registry.
Okay, okay. So you know actuator.
Yeah, actuator is basically like it provides some set of URLs, like endpoint URLs, and that basically gives us the insights into the like for the health matrix configuration and all. So we can get all these things about the application through this actuator. So yeah.
Okay, so can you tell me some of the endpoints or features?
Yeah, sure. So, for example, if we have health check we have to do, so in that case, we can say health, actuator health. So, matrix, we can say actuator matrix, and then we have, suppose we want to show the environment properties and configuration properties. So, we can say, I think, env. And suppose if we want to check and configure the logging levels of the application, so that we can use loggers. So yeah, so these are the some of the endpoints are there.
Okay, okay. Okay, so you have the experience on microservices, right?
Yeah, yeah, I have.
So can you tell me what are the design patterns are there in microservices?
Yeah, so we have API gateway pattern. Okay, so basically that is a single entry point for all the client requests, as I told you. And if it basically routes the request to the appropriate microservices, and it handles the things like authentication, logging, and like rate limiting and all that, it can be handled at the API gateway. Then we have service discovery pattern. So that is basically, as I told earlier, like microservices will register themselves to the some central registry system like Eureka and all. Okay, and then we have a circuit breaker pattern. So suppose if one microservice is trying to reach out to another microservices, and for some reason that is getting failed, or that is not getting connected, or that is not up. So at that time, a circuit breaker pattern can be used to handle those kind of situations of repeated failures. So it basically gives the fallback mechanism, and we can write other method what should happen in case of those kinds of failures. And then we have saga pattern is there. So that basically that manages the distributed transaction across the multiple microservices. So that is one is there. And yeah, so these are the ones I can recall right now.
Okay, so how do you handle configuration in microservices environment?
Yeah, so like we can use centralized configuration services like Spring Cloud Config to keep all the configurations for multiple environments, maybe dev, staging, or production. So in one Git repository. So services fetch their configurations on a startup and can even refresh them at runtime without a startup. So yeah, so this is how we manage the configurations of the different environment.
Okay, so how do you monitor and trace in microservices?
Yeah, so for that, one is the we discussed actuator, right? So we can use that one for to health checks and metrics. And then for dashboard view, if we want, we can use Prometheus or Grafana, so that we can use. And if we want the like tracing of distributed tracing kind, then we can use Zipkin for that. So yeah, so these are the tools we can use.
Okay, so suppose if we have to scale our microservices architecture, so how will you do that?
We want to scale it. Okay, so uh, so scaling can be done in basically two types. One is horizontal and vertical. So with microservices, we generally go for the horizontal scaling. Okay. So whenever we like I mean start up more and more instances of the service based on load. Okay. So to achieve this, we usually containerize our service using the Docker, and we deploy them to we deploy them using Kubernetes. So Kubernetes automatically scales pods using the horizontal pods autoscaler based on the metrics like CPU memory and even custom metrics. Like request per second and also those things we can configure, and it automatically scale up and scale down. So we don't have to do it manually, and we also scale databases independently, and we cache frequently access the data using Redis, and use asynchronous processes like Kafka and all to decouple heavy background jobs from the request and responses. So yeah, so this is how we it can be scaled actually.
Okay, so for the testing of microservices, what steps do you follow and how many types of testing you do?
Yeah, there are different types of, one is the we start from the unit testing. Okay, so like each block of code, or each microservice, we can say each service logic, we can say, so that we tested using JUnit or Mockito. And then we have integration testing. So with to test of containers or embedded databases, we do it after integrating it. And then we have a like one more testing is there. So that we, I mean, some cloud testing or something we say. So that basically we check the compatibility between the services. So if I mean one API is compatible with another services, and then we do end-to-end testing. So we can use, I mean, Postman or some other tools are there. So we can use any of those tools to do the end-to-end testing. So yeah. Have you used Swagger for the testing? Yeah, yeah, we can also integrate Swagger from the very beginning. So whatever the APIs we write, so it will be keep on appearing there at the Swagger path, and from there also we can test it.
Okay, okay.